Okay, hi. Okay, so let's go through your week 3 holiday homework answers. Okay, question 1. So question 1 is basically asking you which of the following shows that it is not pure. So this means that this is a purity question. So it's a purity question. So if you recall, pure substances melt and boil at fixed temperature. We know them as melting point and boiling point. Okay, so let's see. Answer is B. Why? This means that, okay, if you recall, impure substances melt and boil over a range of temperature. An example would be water. So this is temperature for water. So we know that water 100 degrees, that's when it boils. So this is the boiling point. And 0 degrees is the melting point. So let me use different colors. So this is pure. The blue arrow is pure. But when it's impure, it will melt and boil over a range of temperature. So hypothetically, I'm gonna come out with the temperature. So impure means it will melt from 0 to -4. So this is impure. Likewise, it will boil from 100 degrees to 104 degrees. So that's why B is the answer. A does not tell you that it's not pure. A merely tells you that, option A merely tells you that the melting point is lower than room temperature, which is lower than the boiling point. It doesn't really tell you much. Okay, C, it tells me that something evaporate easily, right? Something that evaporate easily, there is another term for it. We call it volatile, which basically means it has a low boiling point. That's all. D, petrol is a highly combustible liquid. It just tells me it is likely to react, I guess, but it doesn't tell you about purity. So B is the answer. Okay, question 2. So you are supposed to improve the separation of the liquids. Sure. So answer is, okay, A is wrong. Why? Because A actually will make it more dangerous. Because there may be a build-up in pressure and it will boom. So actually no. Answer is B. Because when you have a thermometer at Q, it let you know the exact temperature of the vapor. Not just any vapor. The vapor that is pretty much about to enter the condenser. So if you know the temperature, then you are able to separate them more accurately. C, you fill tube R with glass beads. Tube R with glass beads will increase the surface area for the hot vapor to condense on. So actually, if you think about it, I guess, so the question here says best improve. I think C is better than B. Because why? Because you see, when you have additional surface area, so it means that your so regardless, so there are example, there are two liquids, right? So both liquid will, okay, at the boiling point, one of the liquid will boil, become gas. The other liquid will evaporate and become gas. So evaporation is like imposter lah. It is a gas, but it doesn't have enough energy. So that's why when R is filled with your glass beads, it gives it enough surface area for the imposter to actually condense and flow back down. This means that the gas that enter the condenser is legit the real gas. So C is the better answer, I guess. Okay, D is wrong. This merely just allow smooth boiling. Yep. Okay, next question. Which statement about atoms is incorrect? A nucleus always contains proton and, so you see, I see this word always. Always is, in English we call it an absolute term. Absolute term means there's no exception. So it means that it is a little bit sus. Because as you have realized, hopefully you realize that chemistry have general laws, but every now and then you have some random exception, which is a bit annoying. So, okay, this question is asking you which one is incorrect. So this is false. Why? Let's just take hydrogen as an example. 1, 1. So in this case, it has 1 nucleon, which if you look at it carefully, it is actually the 1 proton and 0 neutron. Option A say you must have proton and neutron. Wrong, you know? Okay, B is true. Because why? You see, if you recall, a neutron is at 1 gram relative mass. Proton is 1 gram. Electron is very light, 1/1836, which is very, very light. So in this case, they say that, nearly all the mass is in the nucleus. Correct, because why? Electron is light. So electron is in the shells orbiting around in that sense. So the other things is neutron, proton, which is in the nucleus. This is just neutron plus proton. So this is true, which is not the answer. The number of neutrons can be equal to the number of electron. True. For example, neon 2, 4. It has 2 proton, 2 electron, and 2 neutron. So it is equal. And the last one is true. Nucleus is very small compared to the entire atom. Yeah. Okay, next one. So it says what? A dilute solution of sugar. So this is kinetic particle theory, but a little bit more irritating because it's talking about aqueous, which we usually don't talk about aqueous. So you see, okay, don't panic. Dilute means there is a lot of water. So sugar is very little. So that's why we will say that the sugar is widely separated. Because you have less sugar. You have a lot of water, means comparatively they are pretty much, you can find water almost everywhere because there's so much water inside. So B is the better answer. The question is a very classic diffusion question. So you have oxygen. So the MR of oxygen is O2, which is 32. So question says what? Which option will allow the water level at Y to go up? So water level goes up means there are more gases entering in. Than the gases coming out. So your gas will diffuse in faster than oxygen diffuse out. So your gas diffuse into the pot faster than oxygen diffuses out of the pot. Because oxygen is quite big, it's quite slow. Because when this happens, there are more gases inside in the pot. That means you exert a pressure to push the liquid down, and at Y the liquid will go up. So you realize that the gas must diffuse faster. That means the gas have a lower MR, lower than 32. So answer is C. This is 44, 71, 16, 48. This answer is C. Question 9. Okay, so let's take a look. So don't panic. Let's figure out what's happening. So I like it when they tell me the number of proton, because number of proton is quite unique. If I know the number of proton, I will know which element it is. Yes, 8 proton. 8 proton is 2, 6. 2, 6 is oxygen. This tells me that it's O. Then the 8 proton and 10 electron tells me that there is a net charge, or there's a charge basically of 2 minus. So together you will get O2 minus, which is an ion of oxygen. Next one, a sodium ion and a lithium ion, they have 8 electrons in the outermost shell. A number of you would think that is correct, but actually you must be careful. Why? So you think lithium is 2, 1. Lithium plus is 2. Where is your 8 electron? Isn't it? So do they possess the same number of electron shell? Let's take a look then. Sodium is 2, 8, 1. So Na plus is 2, 8. So it is not the same. One has 1 full valence electron shell, the other one has 2 full shell. They have the same number of neutron in nuclei. Neutron. So if you look at the periodic table, lithium is 3, 7. So that is telling me that this one has 4 neutron. For the other side, if I'm not wrong, Na is 23, 11. That means I have 12 neutron. So they are not the same. So answer is D. Why? Because they both have what I call full valence electron shell. Because once it's full, you basically have no need to gain, lose, or share electron anymore. It's just not reactive, no? Okay, next one. Okay, apparently at room temperature, tin is white color. And then that's room temperature. Then below 15 degrees, your tin will change into gray tin, which has apparently a giant molecular structure. So let's take a look. So option A, white tin can conduct electricity, is true. metals can conduct in solid, and molten. Yep. Whereas the giant covalent tetrahedral will remind you of the word diamond. So you can treat it as if it's diamond. So white tin, which is the metal, can conduct electricity. True? Grey tin, which is your diamond cannot conduct. So A seems correct. Let's check the rest as well. So A, white tin, is hard. It is not hard, right? Because it's just tin. Both white tin and grey tin are malleable. They already say grey tin is like a diamond. It's like, diamond is not malleable. Both of them are soluble in water. Then again, you mean your diamond can dissolve in water? No, right? Yep. Question 12. So it's telling me that what's happening here? 776 degrees Celsius is your boiling point. 320 is your melting point, and you have a real temperature of 600 degrees. So it's saying that they are telling you that, at 600 degrees, it is a liquid, right? It conducts electricity without decomposition. That means the electricity can flow through and nothing will happen, which means it's pretty stable, I guess. So U will be, so you have a pretty high melting boiling point. Yeah. So what is it likely to be? And they also say that if you heat to 600 degrees, which is pretty high, your U can conduct electricity. So it's a liquid. So it's telling you a molten, it can conduct. So high melting boiling point, molten can conduct. So actually, it's telling me the answer is a metal. Okay, next two is calculation. Sure, let's calculate. So you're supposed to find the molecular formula, which is the real formula of this. So this is essentially just a empirical formula, molecular formula question, which means you need a table, not that table lah. So if you remember the hashtag hack for mole questions, like mole in general, first thing, equation. In this case, not really a reaction per se. And second, you will change to mole. They look to give you anything but mole. And lastly, just compare the mole ratio to find whatever you need. So first step, element, which is your C and H, not H2, because it's empirical means simplest. So you are given percentage by mass. (84.2% is your carbon, which means 100 minus 84.2 equal to 15.8. Then you realize, change to mole. So 84.2 divided by 12. .017 for SF. Then lastly, ratio, which means you just compare it against the smallest ratio here. So 7.017 divided by 7.017 equal to 1. Like, yeah. 15.8 divided by 7.017, so you get 2. That means the empirical formula is 2 lah. 1:2. So it's CH2. You're supposed to find out the real molecular formula. So actually you see CH2, does any of these here fits the pattern? Actually is C or D. Because these two, if you simplify them, you end up with CH2. But how do you know which is the real answer? You can count the percentage by mass. So for example, let's test it out. So option C, I take 7. So 7 times 12 divided by 7 times 12 plus 14. Just to figure out the percentage per se. Times 100. 7 times 12, 84 divided by 84 plus 14. You get an answer of 85.7%, which don't tally with it. This is for C, so C is wrong. Answer is D. D. Let's prove to you. 8 times 12. 12 plus 61 times 100. 8 times 12 divided by 8 times 12 divided by plus 16. .7% as well. Yep. Okay, let me press calculator again. 15.8 divided by 7.017. Oh no. So actually there is a mistake here. It's not 1:2. Because why? If you calculate it, you get 1:2.252. 2.25, if you leave it to fraction, right? Isn't it just means that it's 9/4? So this is 4/4. So therefore it is C4H9. Answer is B. Okay, next one. Let's take a look. Okay, you have sodium, which reacts. Then after which it will... Okay, so this question, technically you have not learned enough information. So if you can't do it, don't worry. So I'm going to show you what extra information you need to know. So we'll learn later on that sodium will dissolve in the water, react with water to form sodium hydroxide. So that is the equation which we have to be given. So now that we have the equation, so if you recall the hashtag hack for mole, which is above equation, so this is your equation, then you will change to mole. So mole of Na 2.3 divided by 23 equal to 0.1 mole. Yep, so this is the orange, step 2, changing the mole. So then afterwards you have 2Na, which we can see from the equation. 2Na is to 2NaOH. NaOH is to Na. 2 is to 2, which is 1 is to 1. So this is 0.1 mole. That means this is also 0.1 mole. Okay, molarity is a term that you may not be so familiar with. It's basically just concentration. So the concentration of NaOH is the mole divided by the volume, which is 250 over 1000. So 0.1 divided by 0.25. You get 0.4. Yeah, let's take a look. Did I press something wrongly? 2.3 divided by 23 is 0.1. 1 is to 1.1 divided by 0.25. You get 0.4. 0.4 mole per dm3. But it seems like there's no such answer. There might be some error here. Yep. So answer is E. Okay, 3 more page. Let's go. Okay, so which of these atoms or ions have the greatest number of protons? Very simple. Isn't all these numbers, the smaller number is what we know as proton number, isn't it? So just by looking at it, I know already. Greatest would be 70, 31, Ga. Because 31 is bigger than the remaining number. Then after that, they ask you which one have the same number of neutron. So if you recall, the red number minus the orange, the bigger number minus the smallest number, right, will actually give you the number of neutron. So this one you have 20 neutron, 32 neutron, 39 neutron, 30 neutron, 30 neutron, which means the answer in this case is same number of neutron. So it's Mn2 plus 55, 25 and Ni 58, 28. Yay. Okay, so if you recall, for for bonding, I mentioned before 3 things they are the test. I'll expand it to 5 things now. So it is your dot and cross, it is your melting boiling point, it is your electrical conductivity. So the usual 3 still remains, just that now they will ask this. Why is alloys hard or stronger, but your pure metal is soft? And why is diamond hard, graphite soft? These 5 things you can guarantee that they will ask. So how do we show the structure of an alloy? Don't need to worry. So let me draw the example of a pure iron. Pure iron will be like just circles that touch each other, and they are very regular pattern. But when there's an alloy means yep. So how do you explain the harder thing for alloys? So I will usually start off by telling them in pure iron, the regularly arranged layers of atoms are able to slide over each other easily. Therefore, it is soft. Remember, this is the one that has 3D, not three-dimensional, but 3 words that starts with the alphabet D. So in alloy, first the different of different size. And the third one is disrupt. Disrupt the regularly arranged layers of atoms. So cannot slide over easily anymore. Therefore, it is stronger. Two more page. Let's hang in there. Okay, question B9A. They say ice, which is essentially just water, right? It has a low melting point. Yeah. Because covalent bonds are weaker. This is definitely wrong. First and foremost, get it clear. Covalent bond has ionic bond. It could even be stronger. So this is essentially explaining a melting boiling point. So you tell them, lor. Ice is your covalent compound. Is a covalent compound. Exists has simple molecular structure. So let's think, do you have atoms, molecules, ions, or electron in a covalent bond? So your molecules are so very little energy needed to overcome the weak intermolecular forces of attraction between the molecules in ice. So I disagree lah. Basically, your covalent bonds for it doesn't break. Okay, for B, this is the one. Why is it? Oh, this is melting boiling point. Sure. So let's explain. So, okay, they tell you that silicon is like a diamond, which is your strong molecule, the strong covalent bonds. So tell them, lor. So silicon has covalent bonding present. Yep. And exists as a giant molecular structure. So now a lot of energy needed to break because you are breaking a bond. Break many strong covalent bonds between atoms in a giant network of atoms. So you might be wondering why you must write so much, because you are talking about a giant molecular structure which is like an infinity. So we try to explain something so deep using words. There's limitations, so we need to write more. So the many strong covalent bonds between atoms in a giant network of atoms. Therefore, it has a high melting point. Let's take a look at the next question. So diamond is described as hard and graphite is soft. So tell them, why is graphite soft? So in graphite, so it's 2 marks lah basically. So you say that graphite has covalent bonding present. And exists as giant molecular structure lah. Yep, then after that, little energy needed to overcome your weak IMFOA between what? Between the layers of graphite. That's why it is soft, it is slippery. Okay, next one. Diagram to show the bonding in copper. So you need to show me. So do you remember how we talk about it? So it is first and foremost metallic bonding. It is described as cations in a sea of delocalized, which is mobile lah, delocalized electrons. How do we draw it then? Very simple. So Cu2 plus, Cu2 plus, Cu2 plus. So one Cu becomes Cu2 plus, you lose 2 electrons. So this time round is 3. This time round, I choose to draw 3 copper ion. That means I need 3 times 2. I need to show 6 electrons somewhere inside. That's about it. And the very last part. So they say that the copper wire is made of copper, which is oxygen-free copper, which is just copper lah. But they say that when it's apparently cooled and solidified, some oxygen goes in. So what happened? Why does it decrease the conductivity? Very simple. The oxygen reacts with your metal to form oxides. Yep, which means so you tell them lah. So this one is 4 marks, a little bit long. So you tell them copper, molten copper can conduct in solid, and molten due to your C of delocalized electron. But now that some oxygen is present, how do you explain such that the conductivity is lower? That means there is lesser Cu left. Lesser metal left means the conductivity will drop by a bit. That's about it, right? Okay.